After getting this year's Physics Nobel Prize in quantum information, many of us are confused in the thought, is it really worth it? When I say worth, it means where are we heading in quantum mechanics, or more precisely, is it just our curiosity about science, or can we really make use of quantum computers in our daily life? What benefit do we get from quantum computers over classical computers? Let's find answers together. If we look back in history, we find that quantum mechanics is an essential fragment of modern physics. If we search for the history of quantum mechanics, we get to know that it basically started with a number of scientific discoveries that include the discovery of cathode rays by Michael Faraday in 1838, the statement of black body radiation problem by Gustav Kirchhoff, the Ludwig Boltzmann proposal about the discreteness of energy states of any physical system. In 1877, the discovery of photoelectric effect in 1887 by Heinrich Hertz. One of the major hypotheses in quantum domain was by Max Planck that any energy radiating atomic system can be theoretically divided into energy elements. Explanation of photoelectric effect. Light itself is made up of quantum particles in 1905 by Albert Einstein, which in 1926 came to be called photons. The expression quantum physics was first used in the Planck universe in the light of modern physics in 1931. In the year 1923, Louis de Broglie explained his theory, which stated that particles also manifest wave nature. The origin of wave mechanics and the non-relativistic Schrödinger equation is directly related to approximation of de Broglie's theory. We came to know about uncertainty principle by Heisenberg in 1927. With further unification and formalization, quantum mechanics permeated many disciplines, including quantum chemistry, quantum electronics, quantum optics, and quantum information science. Since quantum mechanics deal with interaction of matter, particles on a subatomic level, it plays a critical role in development of modern technologies. Okay, that's enough about history. When we want to compare the computers in both domains, we must know the building block. In classical computers, the fundamental block is called bit, while in quantum computers, the bit is replaced with qubit or quantum bit. What's the difference? Classically, the data is characterized by a bit. A bit is a basic unit of classical information. It can take two possible values, either 0 or 1. In contrast to this, quantum bit is the basic unit of quantum information. Qubit can take many values at the same time in the form of 0 or 1 or superposition of both 0 and 1. This right here gives us the foundation of why quantum computers need so much more attention. Speed up is the answer. In the same cycle, when classical computers deal with two states, quantum computers deal with many states, which means much more data. Data per cycle increases to an immense level. Mind-boggling, isn't it? Let's understand it with a real example. The problem is called prime factorization. N equals p times q, where p and q are prime numbers. If n is given, we can reach prime numbers p and q with an efficient algorithm. Let's say n is equals to 3233. The p and q in this case are 61 times 53. With the increase in digits of number n, it becomes harder to find prime numbers p and q for the same number. In fact, there are certain numbers whose prime factorization has not been achieved yet. Quantum Shor's algorithm can find prime factors much faster than classical computers. Shor's algorithm can potentially solve prime factorization in a few hundred seconds, while a classical computer can take a couple of years, if not more, to get to a solution. Since quantum computers can solve problems like these in seconds, that's why we need quantum computers over supercomputers. Quantum Shor's algorithm is just one glimpse. Imagine other benefits as well, which includes quantum cryptography, quantum teleportation, quantum information, quantum machine learning, and much more. Let us know in the comments if you want to learn about these concepts. The future quantum holds is bright, and to answer you, yes, it's worth it. Now we know the main concept behind this. What is really happening? Just hear me. Qiskit is the software that sits between quantum algorithms from one side and the physical quantum device from the other. This means anyone outside of the IBM QLab can program a quantum computer. This means we're already programming on quantum computers available to us by many developed countries. Thank you for joining us in this video. If you want to know more about quantum fields or quantum applications, feel free to comment below. Don't forget to like, subscribe to our channel, and watch our other amazing videos.